exam 1. In the exam 1 lecture, the last lecture, so if you still remember it, we could go back to see. If you we can just let you memorize back. We can go back to see in our exam 1 or exam 2, lecture 1 pretty much. When we talk about the bacterial control, I mentioned, so not this guy, then later. Let me show you. I need to show you here because this one pretty much is important. Okay, right here, the control. Okay, the microbial control we mentioned about. What? This is CPC. Centroprotein chloride, that's CPC. And I said this is using for the birds before and after chilling. That's the structure of CPC, okay? That's what we talk about today. Not many people are using, 5 or 6%. Bromine, nobody is using. That's almost out of the market right now. EO, electrolyzed water. This is a very interesting stuff. We did several research 15 years ago when I was a student. We did several things. So what happened is, we wanted this comes out. Hypochlorous gases comes out, maximum as possible. So people think there's an easy way to do. I use salt. Okay, of course, this is food grade salt. Not really the salt, the chemical grade, okay? I'm adding oxygen, I have not added water. How to break down the water? Remember, covalent bonds is very strong. Use electron. Use electricity, then breakdown becomes what? Sodium hydroxide and what? Then they think this is antimicrobials. And what is this guy? Detergent. Yeah, it's a very smart way. But what's the challenge? The pH is going to be lower. Because lots of acid are going to generate. The H is going to be generated. So, at the beginning, electrolyzed water, EO is electrolyzed water. The electrolyzed water is always acidified. So we call it acidified electrolyzed water. Then they add a filter brain right in the middle, can separate the acid and the non-acid part, so finally becoming neutralized electrolyzed water. But not many people are using. The machine is about $80,000. I did that before. It's very expensive. However, EU approved to be used. European countries, Netherlands, Belgium, Italy, Spain, especially Spain, they approved it to be used because ideally they will not generate chlorine byproducts. They will be dominant with basically free chlorine. But I tell you one thing, I tested that. It still could generate, but the level will be very low. So that's a smart way to generate electrolyzed water. But the only issue is at the beginning, lots of them are acid. It's corrosive. So later on become a non-neutralized, or become a neutralized electrolyzed water. Okay, so this is something we want to talk about these chemicals. Okay, chilling process. That is after inside, outside the bird's wash. We put our birds into a chilling tank with ice water, basically 5 degrees Celsius. This is the most effective way to killing bacteria. Why? It is at least 45 minutes to 1 hour. Sometimes it's 12 hours, sometimes 24 hours. It really depends. Because it's enough time to let the bacteria expose to the antimicrobials, enough time to killing them. Again, the number one chemical using the chilling processing is peroxyacetic acids, followed by chlorine. The others are very limited to be used. Okay, here comes a big tricky. And I said here, remember, During the scalding processing, I said that the temperature you cannot lower because you are growing bacteria. Some of the small processors said, okay, I'm going to using higher temperature, 70 degrees Celsius, 65 degrees Celsius. Now what's going to happen? The fatty acids will be extracted, accumulated on the surface. So during the chilling, what's going to happen is it looks like that. All the fat comes out from the skin surface, is accumulated in the chilling tank. It looks horrible, that chilling water. And especially if you are the chilling tank, you're using antimicrobials, is chlorine. Then I want to tell you one thing. That is maybe better than nothing, but there's not many antimicrobial effects at all. Because the fatty acids is an organic matter. They will dramatically decrease the free chlorine concentration from 50 parts per million to 0.5 in less than 30 seconds. And later on, this solution is become a good reservoir for generate cross-contamination. If one of the birds is cross-contaminated, you already cross-contaminated. So this is what happened. The research showing, if your chilling tank is like this, using too high scalding temperatures, the fatty acids accumulated. If you're coming, the percentage of salmonella for the birds is 40%, then you come out, it will become 53% positive, because the cross-contamination will be dramatically generated during this process. So that's why the scalding temperature control here at the beginning is very important. Otherwise, the fatty acids will be accumulated in the chilling tank. So what we should do? We should do the chilling water is like that, very clean. Okay, like that. And some of them use like that. Okay, I just want to tell you, this picture is not from United States. This picture is from El Salvador. And this picture is from Chile. I just want to tell you, they just take the picture in the South America. South American country did a much better job than us regarding the chilling tank, the water quality. That's really good water quality, and this is really good. Most of the time, saw lots of the plants in the United States looks like that. That's not good at all. So these two pictures coming from El Salvador and from Chile, okay? Okay, how about the EU? European countries, they don't do chilling tank, they do air chilling. So just go through the hot, cold air. The chilling about like 48 hours, probably 2 days. If that looks good, well, maybe fine, but not really going to killing bacteria too much during this process. So, we come out with a survey study. Percentage of salmonella positive broiler coccyx exiting the chilling tank in the United States, European Union, and Australia. And very happy to tell you, the percentage of the carcasses positive for salmonella after post-chilling in the United States is the best in the world. It's only 5%. The post-chilling of the EU country is about 15% because they don't use antimicrobials, they do the air chilling. In Australia, as high as 35%. So we are still best in the world, to be honest. How about Campylobacter? 10%, around the limits of the FSIS regulation, but still better, much better than the other country. The average in European country, 70% of Campylobacter. Post-chilling Australia, 82%. So, based on so many years work really hard, we're still good. Okay, just the survey data, but this data is 10 years ago, but I don't know right now, maybe change a little bit, but we're still much better than lots of the other countries in the world. Okay, how we do in the West Virginia? West Virginia, there is a lot of small local growers. So what they do? They are using mobile poultry processing unit. This is what the Department of Agriculture is trying to do. There is a two type of the mobile poultry processing unit. This is open air MPPU. The unit $30,000, can process in 90 birds per hour, is 50 to 300 birds per batch. Now what's a bad thing for this? There is not all the wastewater is captured, surface partially be cleaned. You can clean very well. This is what the big one is, the enclosed MPPU. They have one in Charleston, close to the Department of Agriculture of West Virginia. That's $90,000. 100 birds per hour. There's 200 birds per batch. It is also could be USDA FSIS inspected. And the wastewater, solid waste could be collected and the more good surface cleaning, which means the biofilm control could be much better. That's enclosed MPPU. But there is a $60,000 difference of the cost. To keep in mind about that. This is the one when I took the picture 5-7 years ago when Dr. Joe Motz did a workshop in Marshall County, close to Wheeling in West Virginia. So we hang in there and the bleeding exquisition, we do the scottering, we do the defeathering, and we manually using hands to do the evisceration, and the last one is using the chilling tank. And this is his trailer, can go everywhere in the West Virginia to do the training, to the outreach training. Okay, so that's very interesting project for the, and I'm doing some of the things with my graduate students. We are trying to see every steps, how many bacteria are still there, how many APC and the coliform are still existing, or they still have a salmonella or campylobacter, and we find that the processing here is really good. There's no salmonella can be isolated, but the campylobacter is still a huge amount. So just want to let you know, okay? So this is all I have for this process, for this section. This is, tells you about the microbial safety of the poultry processing. So we will move on to immunology after the Thanksgiving holiday.